A snowball in the shape of a sphere is melting. If the radius of the snowball decreases by 3%, use differentiation to determine the approximate percentage change in the volume of the snowball. So, V is 4/3 pi r cubed. So dV dr is 4 pi r squared. We know that that means that delta V is approximately dV dr delta r. Now we want to make this into a percentage. So delta V over V multiplied by 100 is going to be, now dV dr is 4 pi r squared. We want to divide by V because we have to do the same to both sides, but this time I'm going to write this as 4/3 pi r cubed. And then we have delta r, and don't forget we need to multiply this side by 100 as well. So delta V over V multiplied by 100. We simplify this. 4's cancel, pi's cancel, r's cancel down to this one on the bottom, and dividing by 1/3 is the same as multiplying by 3, so the 3 comes up to the top, and we've got 3 delta r over r multiplied by 100. So, if we know that this, the change in r, sorry, I just circled the wrong bit, and let's use a different colour. This bit is the percentage change in r, and so what we get is 3 times -3, so 3% decrease up here, so that's going to be -9%. The angle of elevation of the top of a building measured at a distance of 20 meters from the base of the building was written down as 60.5 degrees. If the angle of elevation was actually exactly 60 degrees, use differentiation to determine the approximate error in the calculation of the height of the building. So clearly this is going to be based on trigonometry. So if the measurement is taken from here, let's call this theta. Right angle triangle, we know that this is 20 meters, and this is height. So the height would actually be equal to 20 tan theta. Think about it, tan theta is equal to h over 20, and just rearrange. Now clearly we're going to need dh d theta because we're going to be doing delta h in terms of delta theta. Now you should know that tan differentiates to 1 over cos squared. So this is 20 over cos squared theta. So we have delta h is approximately 20 over cos squared theta delta theta. Now, looking at what we have here, theta was equal to 60.5 degrees, but remember we're in radians when we do this type of thing. So that is 60.5 multiplied by pi divided by 180, and that's giving me this. I could have tried this in standard to see if it gave me a 121 pi over 360. And then delta theta is 0.5 degrees. It's actually negative 0.5 because it's a decrease. So negative 0.5, use the wrong negative, let's clear the line, negative 0.5, let's multiply that by pi divided by 180, and that's negative pi over 360. I used an approximately here, which isn't strictly speaking, you're not going to get marked wrong for something like that, but it's not strictly speaking right. So, delta H is going to be 20 over cos squared 121 pi over 360 multiplied by negative pi over 360. So, need to calculate that. So I've got 20 over cosine of this angle and that needs to be squared, and then we're multiplying by negative pi over 360, and I'd really rather have this as a decimal this time, so that is going to be negative 0.72 meters, correct 2 decimal places.